Okay, now that we've covered the new functional APIs like input, output, and the various child queries, let's talk about something cool that's not purely signal related, but works really well with it: router input bindings. Consider the following example. Now we have a minimal application here that shows you details about movies. Now, as you can see, if you look at the app component HTML, you see that we have a navigation panel on the left, and then we have a router outlet right here on the main area. And the router outlet presents a component according to the route. Now, if none of the movies is selected, we can see the home component here. But if you click one of the movies in the navigation pane, you see that we route to the address movie / and some ID. In that case, we load the movie details component. Now, the movie details component is being reused for all routes that present a movie. Okay, so we have many various different routes, each time with a different ID, that use the same component. This component, of course, needs to know which ID, which movie ID we want to present. So the way it receives this information is by using the activated route. Activated route is a service provided by the Angular router that allows you to receive the route parameters using the .params property. This returns an observable of params. The reason this is an observable is because when you move from one address to another where both addresses use the same component, the Angular router does not destroy the component, but instead it simply injects different data into it. So we're using the same instance of movie details component every time we change route, only the ID changes. So of course we cannot receive it as a static snapshot value. We need to get it as an observable, which is why we receive the params as observable. The value of the observable is a collection of key value pairs mapping between various parameters inside the route and their values. Of course, in our very simple case, there's only one parameter, but you could have more than one part of your URL, which is dedicated to a changing value, which is a parameter. So in our case, the only parameter we have is called ID. And what we do is we extract this param and then convert it to a number, because all parts of the URL are always injected as strings. Now that we have created an observable of ID, we rely on it to create an observable of movie. We combine values coming from a service. Now, this service already provides us the information as a signal rather than an observable. But of course, traditionally, we would have to use operators to combine two streams of data. One, the observable of movies, and another one is the observable of ID, to receive the specific movie that we want to watch. Now, since we're using signals in the service, this becomes a little bit easier, but we're still using observable here. So we're using various RxJS operators to create the two observables that we need for our view, the observable of movie data and observable of poster of image, and then we present them in our component using the async pipe, which we can see here. So the async pipe is presenting the various observables, is used to present the various observables that we have created. So while this code is okay, this is actually the best practice until Angular 16. Now, with Angular signals and the new feature that I want to talk about, we can actually simplify this. So instead of the old way, where you had to inject activated route and deal with observables just to get route parameters, you can now bind them directly to component inputs. It's a much cleaner and more elegant solution. And when you combine this with signal-based inputs, you get a powerful way to react to route changes in real time. It's a pretty seamless way to handle routing and make your components more usable. So let's demonstrate how we would do the same thing in the new way. The first thing we need to do is we need to enable input bindings in the router. We need to allow the router to automatically feed the parameters, and not just parameters, by the way. You can also do that with resolver data and with the static data parameters, and of course with the query params. So you can do it with everything in the router that could change. So we would like to tell the router to feed the data into the component inputs rather than receive them using the activated route service. To enable this feature, if we look at the provide router function, which configures the dependency injection for the router, we can see that it receives an optional list of router features. Each feature is provided by a function that starts with the word with. If you write with, you will receive a pretty big list of extension functions. These are functions that return something that extends a feature. Now you can see that some of them deal with the router, but the same architecture is used also to extend HTTP and animation, and there is pretty much, you can see that there's a pretty big list for quite a lot of different aspects of the of Angular's configurable services. Specifically, we want to use the component input binding feature. So this is returned by the with component input binding function. Now that we've called the function, and of course we can use other router features to extend the router even farther, but now that we've supplied the feature that this function returns, the router automatically injects the ID and other parameters into our component inputs, and we just need to receive them. So we will now go to the movie details component, and instead of receiving the ID through the activated route observable, we can now receive it as an input signal. So read only ID equals input dot required number. The only problem is that, as we've seen, this information doesn't really arrive as a number. We saw that the router passes strings as values here because all parameters are parts of a URL, and the URL is a string. So we need to tell Angular to convert the value into number. Now, in order to do that, we can use an input feature that is available since Angular 16 that transforms from one value to another when you receive a value as input. So the way it's done is using the input configuration object and then supplying a transform. Now, the transform that we want to use is a transform function that converts from strings to numbers. And Angular core comes with a predefined set of transformers. Of course, you can create your own custom transformer as well. So we're going to use the number attribute transformer. This transformer takes a string and attempts to convert it into a number. Now, as you can see, we have an error here. The reason for this error is that actually the value that it returns is not necessarily a number. It can also be an unknown in cases where the value cannot be parsed into a number. So instead of relying instead of telling specifically, explicitly, what type of signal we expect, we will just let the compiler defer the type, and we can see that we get a signal of number or unknown. Okay, this actually makes sense because it is possible for somebody to write a URL where he uses string instead of a number. For example, typing down movie ABC. And if we do that, obviously the number is not, the value is not the numerical one, and the transformer will fail. So this is the best way to let TypeScript know that what we pass here might not be successfully transformed into a number. Now, just like we canceled the necessity for an ID observable, we can now migrate the other observables into computed signals, because we now have a signal that changes all the time, so we can create computed signals. For example, the movie signal can be computed like this. read-only movie equals computed, where we take the, well, actually we need to check for two things. First of all, we need to make sure that the ID is a number. So this ID type of this, you know what, actually we'll just do it directly. We'll assume the best. Of course we can write the function a little bit differently, but let's just assume this is a number for this case. So so this dot movie service dot movies find a movie so that the movie ID is equal to this ID. Okay, now because we're using the three equal signs, even if the ID is not a numerical, we'll just get an undefined. So movie here is a signal of movie or undefined, and that makes sense. Now, finally, we can calculate the poster. So let's also comment this out and then say read-only poster equals computed, where we construct a string just like here, except we use the movie signal and then poster image. Now, because this can be an undefined value, we will use the question mark dot and then provide a default value of empty string. Okay, so now we can see that we've converted all of the observable values into signals. Now the only thing that's left is to fix the bindings in the HTML, which is pretty straightforward. We don't need to use the async pipe anymore. We can just use signals. So movie without the async. We still need the if because the movie can be undefined. So we want to condition the display on an existence of value. But now we can use the poster and the movie without the async pipe. And we see that it works beautifully. Okay? So it works exactly the same. And of course, the syntax is much more simple. We do not rely on a service. We still work reactively because we use signals and computed, but now the data is injected using the input mechanism, which is, let's face it, this is probably the best mechanism to use in order to receive values from the router. So to summarize, this is the router input bindings feature. And I wanted to show it to you, not because the router input bindings is a part of this course. Basically, this course is about signals, not about the router. But as you can see, when you combine together the new feature with signal inputs, it gives you a pretty elegant way to write code that was previously much more complex and relied on RxJS operators. And now we don't really need to rely on them anymore. No, at least not for these scenarios.